Let's start with a quick quiz. Which of these statements is true? To build an AI system, you need to manually program it to recognize each possible scenario and respond appropriately. Or B, you can build an AI system that learns from its past performance and feedback to get better at a task over time. If you said B, you'd be correct, and that S because the ability to learn from experience and improve over time is what separates artificial intelligence from regular computer programming. But how exactly does this learning process work? That's what we'll explore in this video. First up, let's define our terms. We want to build a spam detection system that uses ML to filter out spam emails. Our spam detection system will learn from the training data whether an email is spam or not. Then we can test our system on a holdout set to see how well it performs. An SVM works by finding the optimal hyperplane that maximizes the margin between different classes. In our example, we want to find a hyperplane that maximizes the distance between the spam and not spam emails. We then classify a new email as spam if it falls on the wrong side of the hyperplane. We've covered some of the basics of ML, including how it differs from traditional programming, some common ML algorithms, and how to evaluate the performance of an ML model. If you're interested in learning more about ML, check out the references below. Thanks for watching, and I'll see you in the next video. We'll also need a metric to evaluate our model's performance. We can use a technique called cross-validation to estimate the performance of each algorithm. We split the data into k-folds and then train and test the algorithm on different combinations of these folds. We then average the results to get an estimate of the algorithm's performance on unseen data. We'll use accuracy for this example, which is the percentage of emails that are correctly identified as spam or not spam. With traditional programming, you would write a set of rules that the computer would use to identify the fruit. Decision trees work by recursively splitting the data based on the values of different features. For example, we might start by splitting the data based on the presence or absence of certain keywords. If a message contains the keyword free, then we classify it as spam. Otherwise, we move on to the next split and so on. Once we reach a leaf node, we assign a class label to it, either spam or not spam. For example, if the fruit is red and round, it's an apple. If the fruit is green and long, it's a banana. It makes the naive assumption that all features are independent of each other. For example, if we have two features, free and urgent, it assumes that the presence of free does not affect the probability of urgent being present. We then classify the message as spam if the probability of it being spam is greater than a certain threshold. With machine learning, you would simply show the computer a bunch of pictures of fruit and tell it which ones were apples and which ones were bananas. After looking at all of these pictures, the computer would use an algorithm to identify the key features that distinguish apples from bananas. In this case, the algorithm might look for a rounded shape for apples and a longer shape for bananas. Once the computer has learned how to identify apples and bananas, it can then use these rules to predict what kind of fruit is in a new picture. Artificial intelligence, or AI, refers to computer systems that can perform tasks that are typically done by humans, such as understanding natural language, recognizing patterns, and making decisions. A subset of AI is machine learning, or ML. In machine learning, we don't manually program a system to perform a task. Instead, we feed it data and let it find patterns and make decisions based on those patterns. The system then uses these patterns to make predictions about new, unseen data. One way to think about the difference between traditional programming and machine learning is to imagine you reteaching a computer to identify different types of fruit. To do this, let's first define our problem. Now let's look at a few common algorithms used for classification tasks like spam detection. Another popular algorithm is called the naive Bayes classifier. This algorithm uses Bayes' theorem to calculate the probability of a message being spam given the features of the message. Finally, let's look at support vector machines, or SVMs. But how do we know which algorithm will work best for our spam detection system? Once we've selected the best algorithm, we can then train the model on the entire training set and use it to make predictions on new data. And there you have it, a quick introduction to machine learning.